Alright, so for the gold points portion of this project, we modified body and Nbodies so that we have the mouse pointer actually act as a body. So wherever that is on the screen and its distance relative to the bodies that are defined in whatever text file you load up, it will act like you'll see all the forces interacting between those bodies and the cursor. So we're going to load up an example. This is just with two bodies. As you can see, when you pull the cursor towards it, the bodies start to accelerate towards the cursor, and like the closer you get, the stronger that acceleration is because the force exerted on the body is inversely related to the distance from the other body. So you can see that gravitational force, and if you get too close, it'll kind of slingshot away. Right now we're controlling it pretty well, and yep, then that can happen once that distance gets really small, because as the distance goes to zero, the force exerted on the body approaches infinity. Now we're going to load up another file. This has 3 bodies instead of 2, and we'll see all these 3 be influenced by the cursor now. The Earth tends to accelerate a little bit quicker because it has a higher mass than the Sun, so it just kind of gets thrown around with a little bit more speed. Just shot off the screen. Now we're kind of, one of them is floating around. We're kind of trying our best to control the other one, and it's gone. And now the third one's gone. Loading up another set now. See everything in orbit. Now the orbit's kind of getting thrown off by the cursor. And Kevin is ours now. The poor guy doesn't really have too much control over his life, and Kevin's gone. Sorry, guy. Alright. Well, one important thing to note is that we do break one of Newton's laws in this modification, because as you can see, the cursor is exerting a force upon the bodies, but the bodies are not exerting any sort of noticeable force on the cursor, and that's just because we wanted the user to retain control of the cursor. Otherwise it would just go into an orbit and not really be interactive at all if the other bodies were exerting a force on the cursor. Another file, twin binaries, we're loading up now, and now we're changing the mass of the cursor. That's the final command line argument that we added in for this portion of the project, is you can specify how massive you want your cursor to be. As you can see, with this higher mass, it gets chaotic a lot quicker because the bodies can't maintain their original trajectory and interaction even when the mouse is really far away from them. Yep, and same thing. Just with that really big high mass, you can see that it's really hard to control. Now we're going to go to a lower mass, and yep, you can clearly see the influence, but it wasn't quite as immediate as it was with the higher mass. So what we learned from modifying the project in this way overall was first how to actually track the movement of the cursor. The largest challenge we had was scaling the distance values such that the readout of the cursor position, which is the maximum value, is the screen resolution, to the distances that we have scaled for this project, which are of astronomical proportions. Getting those two to be on the same scale so that we have the cursor's position actually be in the correct spot was probably the biggest challenge. For a while, every body would immediately shoot to the top left-hand corner of the screen, because we would have the distance, even at the maximum value, be almost negligible, almost zero, relative to the millions, billions, or trillions of miles that are separating the planetary bodies given the scale that we set. So this concludes our demonstration of Nbodies X-TREME. Thank you.